Hello guys, welcome back to Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. In last lecture, we discussed the stresses, strains, types of stresses and types of strain. In today's lecture, we are going to prove one of the important relationship in structural mechanics or the solid of mechanics, in which a change in deformation in an object is equal to the load multiplied with the length of the object dividing by the area and with the E modulus of the material, or we can say the axial rigidity of the material. So we are going to find out this relationship, that how we come up with this important relationship in solid mechanics. So how to prove this, I will go through an example, so it will be more easy to follow and to more easy to understand. So let's suppose this is in a rectangular object, or I call it a steel bar for example, and I applied the load of P as a tensile load on this object P in the tension direction. So what will happen? There will be some tensile stresses generated inside this material, and it will deform the shape of this object. So if I draw the deformed shape of this steel bar for example, or any object, so it will look like this. It will extend in its length and will decrease in its little dimension. So it will look like this. Now it's a deformed shape of this object. Now, so there is some stresses created inside this object to resist this load, and also there is some deformation inside this material, which I call as delta L, which is the change in this length or the increase in this length of the bar or any material, while this L is the original length of the object, which was L. So now we know that due to the application of P load, there are some stresses created inside this object. So we call it the tensile stresses is P divided by A. Now P is the applied load on this object, and A is the cross-sectional area of this bar or any object. If it is a rectangular, then you must find out the area by multiplying the B and H, width and height of the material. If it is the diameter of the bar, then you can find out by the pi by 4 into d square. Depending on the shape of the geometry of the material, you can find the area or the cross-sectional area of the material, and then you can divide it by the load. You can find out the tensile stresses. So we have some tensile stresses created because of the application of the load. And also because of this tensile stresses, what we will have strain in this object. So strain will be equal to the change in length dividing by the original length. Now change in length is this basically, which we have some increase in the length, and L is basically the original length of the material or the object. And we know that Hooke's law, we also discussed Hooke's law in our last lecture. In Hooke's law states that within the elastic modulus of the material, the stresses are directly proportional to the strains. It means if your stress is increasing linearly, your strains are also increasing linearly. So according to the Hooke law, the stress is directly proportional to the strain. Now we can replace this proportionality sign with a constant, which I call it E here, where E, capital E, is basically the modulus of elasticity or Young modulus of the material, and it depends on the material. So now we find out this value, and also now we know that this equation, I can write it here: sigma stress is equal to elasticity into strain. So now this equation, we just plug the values here of the stress. Now stress is this P by A, so I just plug the value of stress into E, Young modulus, multiplying it with E. Now E is here is change in length divided by the original length. So now I want to shift this value, this delta L value. So I have to shift this value, and I have to bring this value here down, and this goes up. So just rearranging these terms. So delta L will become here P. L will go into this side. So P into L divided by A into E, where this E, AE is known as the AE This is known as the axial rigidity or the axial stiffness of the object. Keep in mind, I will explain this also in our next lecture. A is the area of the cross section of the object or the material, and E is the property of the material, elasticity of the material. So you can put the values here of AE and the load applied and the length, original length of the object. You can find the change in length of the object, that how much this object increase in its dimension, increase in its length when the P load is applied on this object. So this is a very important relationship in solid mechanics or the structural mechanics that we use to calculate the change in length when there is a prismatic object or prismatic bar. So hope you guys understood, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.